Good morning, students. Today we are going to discuss one of the most important topic of C language known as pointers. So what are pointers? Pointers are basically the same as other variables. Then what is the difference about the pointers? So instead of containing actual data, they contain a pointer to the memory location where information can be found. So in other words, they stores addresses instead of actual data. So point next is pointer notation. A pointer is declared just like we declare a normal variable. There is only one difference in declaration is that we add asterisk in front of it to indicate it's a pointer variable. So let's look into the examples. If I declare int, we call it star I, that means I am declaring a pointer of integer type, that is known as integer pointer. If I declare float star p, that means it is a float pointer. Similarly, char pointer p means it is a character pointer. So let's understand the pointer notation. So as we said, discussed that int pointer p. Now let discuss what does it mean. It means that p is a pointer which store the address of a variable which is of integer type. So similarly, what does char pointer p means? It means that p is a pointer which store the address of a variable which is a character type. That is, they store the address. So float pointer p, what does it mean? It means that p is a pointer which store the address of a variable which is of a float type. So there are two important operators of the pointers. One is known as a ampersand, another is known as star. Ampersand basically means ampersand is used to find the address of a variable. So if we want to find the address of a variable, we use ampersand. Star. The star basically gives value at the address. This is very important. So the difference is ampersand gives you address of the variable and star gives the value at address. So let's see if I declare a variable, say int a is equal to 20. So in memory, how it will be declared? In memory, a variable a will be declared which will be having a value 20 and address 100. Now if I want to find out the address of the variable, what I will do ampersand a, and ampersand a will return me 100, that is address of variable a. So if I want to get 20 value 20, how I will do? Using pointers, one we will do ampersand star ampersand a. Look into this, star ampersand a. How this will be evaluated? Ampersand a will return the address which is 100. So 100, that becomes star 100. That means what is the value which is stored at location 100? So value which is stored at location 100 is 20. So it will return me a 20. I hope you understand that and the difference between the ampersand and star. Let's put it all together and discuss the memory layout so that it's more clear to you. So I am declaring, as in previous example, I am declaring variable int a is equal to 10. So how it will be done in a memory? In memory layout, a variable a will be declared whose value will be 10 and address will be 500. Then if I declare a int pointer p, in memory what will be done? It will declare another variable p whose address will be 1000. It does not have any value because we haven't put any value into it. Now if I say p is equal to ampersand a, what I am doing here is I am finding a address of a using ampersand and storing that address in a p. So how memory location will look like? Look into this, the third picture. I have variable a which I have value 10, 500. Now this 500 will be stored in a p. So memory location will look like this. There will be one variable p with address 1000 and its value will be 500. That is address of another variable which is of integer type. So this will be the memory layout of the integer pointer. Let's discuss all this with the help of program. Same thing. So what I am doing is, again I am declaring int a is equal to 10. Then I am saying int pointer p. Then what I am doing is p is equal to ampersand a, that is storing the address of a into p. So now the first statement, look into the first statement. It says printf address of a percentage u. For pointers we generally use percentage u, that is unsigned int, because pointer doesn't have an address which is of negative. So we use ampersand u. So always remember to use percentage u for the addresses. So in this first I am saying the ampersand a. Concentrate on this. What is the ampersand a? Ampersand a will give me address of a. So address of a is 500. So output for the first case should be 500. Right. So second, I am saying ampersand p. Consider on this part, ampersand p. So ampersand give me the address. So in this case, what I want to find is address of p. What is the address of p here is 1000. So in this case, answer will be 1000. Here what I am printing is simply a. This a will give me what? Value of a. So here value of a is, you can see, is 10. So output should be 10. Sorry. So next one is I am printing p. P will print me what? Value of p. So value of p here is 500. So answer should be 500. Now look into last two ones. What I am here doing is I am doing ampersand p then star. First ampersand p will be evaluated. So that means I am finding the address of p. What is the address of p is 1000. Then I am saying that star, that is star 1000. Star 1000 means find the value at location 1000. So value at location 1000 is what? 500. So in this case 500 will be printed. Now look into the last one. I am saying star p. So p is a address. So what is the value of p here? Value of p is 500. So I am saying that star p. That means find the value at 500. That is 500. So what is the value at 500 is 10. So 10 will be printed here. So let's do that in using a program. I have already created a similar program. You can say int 810, then int pointer p, then this. The same statements are there. Let's run it and find out. I was using arbitrary addresses, say 100 and 500. Let's see what addresses pick. Okay. The first statement I am doing is address of a. Here address of a, it has stored the a at which address 6487580. So this value is the address of a. Secondly, I am saying address of p. So address of p is 6487568. Then third one is I am printing a. So what is the value of a is 10. So 10 is getting printed. What about fourth? Fourth, I am just printing the value of p. So what p is store? P store the address of a. You can see here I am storing the address of a. So in fourth, address of a should be printed. So what is the address of a is 6487550. So 6487550 is getting printed. That is, I hope you understand this point. Now fifth one, what I am doing is ampersand of p then star. What we will take? First we will take the value of address of p. What is the address of p? 6487568. Then say star. Then value at this. So value at this is address of a. So it will print 6487580. And then last one is, it's a star p, that means value at p. What p is storing? P is storing the address of a. So what I am getting is, I am finding is at a what value I am having there, that is 10. You can see that in picture here. Star p basically means is, star p here what is p stores what, 500, star p is 10. So I hope it is clear to everyone. Now let's discuss the pointer arithmetic. So in C language, only following operations are allowed on pointers: increment and decrement of a pointer, addition of a pointer to an integer, subtraction of an integer to pointer, subtraction of two pointer to same type, and comparison of pointers. So let's discuss the increment decrement of pointer. When we increment or decrement a pointer, it does not add or subtract one. I said does not. It increment moves the pointer to the next memory location based upon the pointer. You remember that pointer stores what? It stores the address. So when we increment a pointer, it does not increment it by one. It increment to next memory location. So we always need to understand that it increment or decrement to next memory location. So what does it mean? If I am having a pointer of integer type. Now if integer takes 2 bytes, then the next memory location will be after 2 bytes. Let's see what I mean is, I have created a pointer. I have created a pointer of int pointer p, and I am storing here as a address of a. When I do increment p plus plus, the answer will not be 501. Integer, if integer take 2 bytes, the next memory location will be 500 plus 2, that is 502. Similarly, if I say p minus minus, then the next location is 498, not 499, because integer takes 2 bytes. If integer takes 2 bytes. Similarly, if I create a float pointers, so if floats take 4 bytes, then if I say p plus plus, it will not move to 501. It will move to 504, because float take how many bytes? 4 bytes. So next memory location will be at 504. Similarly, the previous memory location will be 496. So similarly, in case of character takes 1 byte. So if I increment p plus plus, so it will give me 501. Why? Because character takes 1 byte. Let's see here. Okay, let's do it here only. I'm printing the address of p. Okay. Let's run program to understand this. Let's first print the size of each variable. We have a one function known as size of, which basically tell the size of the data type. Okay, first what I am doing here is, I am just finding the size of a. Here a is integer where. You need to keep in mind that size of integer float changes based upon the what type of system we have. If we are having a 64-bit system, the size will be different. In 34-bit, the size will be different for integer and floats. But the size of character always remains same, that is 1 byte. So what I am doing is, first I am finding the size of A, then I am finding the address of P. Then let's increment that. Then display the Okay, let's run that. Okay, so you can see that the size of variable is 4. So this is a 64 bit, so its integer size is 4. The address of P is 6487568. Then address of P plus 11 is 645864A. So we haven't printed the size of P. Okay, what mistake we have done? We have printed the size of P here, address of P. We need to print up P here. Okay, now you can see that. Previously we were printing the address of both the position, that's why answer was not correct. So you can see that the size of integer variable is 4 bytes. So address its store is 6487572. It's a 4 bytes. So when I say p plus plus, it will goes to the 76. That is a 4 memory locations. Let's change it to char. Let's see what is difference. How many bytes cat takes? Cat always take 1 byte. So let's see the answer. So you can see the size of integer is 1. The address is 6487576. When I do p plus 1, 6487776. You can see the 76. So it always move to the next memory location. Let's do with a double. So double takes 8 bytes. So it will add 68. 8 is 76. So it moved to the next memory location. So how I hope it's clear to everyone that when we increment a operator or decrement an operator, it does not add one. It always move to the next memory location. Let's do p minus minus to see the decrement result. Okay, so you can see the address is 68. As we have done the decrement, it take 8 bytes, so address is 60. I hope it's clear to everyone. Okay. Next is addition and subtraction of integer to the pointer. So we have done the increment. Now if we can add any integer value to a pointer. So in this same example, if I say int a is equal to 10 and if say p is equal to p plus 5, what I am doing is I am adding a 5 memory location. I am not adding a 5. Keep in mind, I am not adding a 5. I am adding a 5 memory locations. If the integer take 2 bytes, the 5 memory location will be after 10. So answer will be 510. If integer take 4 bytes, then answer will be 520. So let's run this. If I say 5 is equal to 5 plus 4. So what I am doing is I am adding 4 memory location. Here I am doing a double. Double takes 8 bytes. So 4 in 8 into 4 is 32. So 32 should be added to the variable p. Let's run it. Okay. So you can see that 68 plus 30 is 568 plus 30 is 600. So it will move to the 4 memory location. Similarly, if I do say -1, it will decrement to the 4 memory locations. The next is subtracting two pointers of same type. So similarly, if we subtract two pointers of same type, it will return me the number of memory locations, not the exact value. So in this example, you can see that if one memory location is 1010, another is 1020, if I subtract it and it's of integer type, the answer should be 5 memory locations. Let me show that. If I say, so what I am doing is I am already having a one pointer p. I am declaring another pointer k, and I am doing adding 4 memory location to this. If I do int mem location is equal to k minus p. Now what will be the result? Result will be difference in the memory locations. Let's print it. So what should be the answer? Answer should be the 4. Let's try to run it. Oh, it's giving me error. So can you figure out what's the error it is giving? I will explain it that subtraction of two pointer of same type is allowed. So here I have one pointer of double, here I have one pointer of integer. So it's not going to work because they're of different type. So we have to make it at a double. You can see that the difference is in the 4 memory locations. Okay, so another important thing is what are the operations which are not allowed on the pointers. We cannot add two pointers, that is P1 and P2. I will show that multiplication of pointers is not allowed, division on pointers are not allowed. So what I mean that if I say, so I am adding two pointers here, it's not allowed. You can see that here invalid operator plus, that is addition of two pointers are not allowed. If I multiply it, same error is this, invalid this. So multiplication of not allowed. So these are the 4 operations which are not allowed, 3 operations which are not allowed on the pointer. That is addition of 2 pointers, multiplication of pointers, and division of pointers. This was all about pointers. In continuation of pointers, in next session we will discuss some other important concepts of pointers. Please do practice it. If you have any question related to it, put it in the comments. I will try to answer that. Please subscribe the channel for updates. Thank you. Thanks a lot.